the data. We want to make sure that the data will be converted into proper science. So in addition to all these things, we train regularly all the other members also. For example, even at the student level, we started training students with a program called START, START. Whereas in the just last year, there was some more than 60,000 students at the level of 9th and 10th participated in that. So we gave certificate to all of them. Out of them, we have selected from each state some 2 3 people, and we actually taken care of all their travel, and we made them attend a program, annual program called National Space Science Symposium, which held at different parts of India. So we had a separate session for them, and they were made to interact. They were allowed to interact with eminent people like our former chairman Kiran Kumar, our former chairman Somnath, and current chairman. Everybody, we gave the opportunity for them to interact and talk to them. In addition to that, we also have something called Yuvika. You might have heard that Yuvika is the Vignan Kalika, something like that, which is for the students again. So there's a 30-day program where some 2 to 3 people from each state are selected, and they're brought to Bangalore and different centers, and we train them for 1 month. After that, we take them to Shar, where the launches happen, and we try to see that the science is inculcated into them, that this one. Okay, so like this, there are a lot of things happening with ISRO, and now we are concentrating only on the research part, so these things will keep on increasing.
My second question is,
एक minute. Before anything else, Cohen International students should force Jyoti ji to get in touch with this guy, Girish, later on, to make sure that you also get involved in that program. It's your responsibility to push him. Yes, please.
so my second question is, how does ISRO decides on its priorities and select the focus area for its missions?
Very good question. We will be answering this multiple times. So there are two ways. One is top down, where the management are the top, what should I say, our leadership decides what we should be doing. For example, Gaganyaan came from Prime Minister's office, said that we have to have our own Gaganyaan mission, and also we should actually have our own space station. Okay, so Bharatiya Antariksha Station is going to come up. It came up because of that. Then planetary science, the management takes a call on which planets we have to explore next, for what, like Chandrayaan, after Chandrayaan, where we have to go, etc. Then there is another thing, the scientists ask ISRO, this is a niche area, we would like to have ISRO mission for studying this thing. For example, just to give one example, so we are going to launch a mission to study planets outside solar system. I mentioned yesterday exoworlds. Okay, this mission came as a part of science community. And in addition to that, you may have heard Astronomical Society of India and many other forums where scientists come together, and PMO office and other people who will actually decide to find out what will be the future programs which will benefit India in 25 years, 35 years, and other thing. Okay, so these people come together, they brainstorm, and they come up with some things saying that, okay, these mega science vision, we call it as mega science vision, because this vision for the future. So they say that these are the science projects which will be very, very helpful for India in future. This one. So in this way, we actually take up all the three. Most of the astronomy things comes from the last one, where the users demand saying that, okay, we would like to have these kind of things. It will help us a lot. It will help India to reach into international level. Planetary most probably is taken at the ISRO level, and then anyway all of these things has to go through the government. Okay. And then these are the science things. In addition to that, we will also have requirements from the communication. For example, your DTH, your phone, all these things need communication. Okay, so those things we actually take it as a commercial thing. Now it is moved to in space. Hence, I didn't mention that. And then one funny thing, not the funny thing, strategic thing, which is required for the security of the nation. How many of you have heard of Kargil War? Kargil War. Okay, thank you. So, in the Kargil War, I am not going into the nitty-gritties of Kargil War. Nowadays, you know what is the importance of location sharing. You call anybody and ask where you are. He'll open his mobile and say that, okay, I'm sending the location. Imagine the importance of this kind of thing during a war. Okay, when we were actually trying to target the enemy, America switched off their GPS. So then immediately we realized the need for such a niche technology which cannot be controlled by others. I'm just giving one example. So when it is required, if we don't have the technology, we will be in a disadvantage. So for that, we started a program called Navik. Navik is India's own GPS technology. I'm saying GPS, but you can take it as GPS is our American term, but GPS is well known now, and hence I'm using that. So like this, we have multiple strata, and also we do have Cartosat kind of series where it will be keep on photographing our Earth, so we can actually use that for enemy movement also. So like this, we have multiple things, and you may ask me a question. All our programs are either looking at Earth for the strategic thing or away from this one for science. What are you doing for Earth studies? We are coming up with a new launch. We are coming up with a mission called Disha. It is going to study the atmosphere of Earth itself. So like this, it comes from different places, like different levels. It can be from the government, it can be from the ISRO management might take a call saying how we can do this later on, and science, like you. You may ask me to say, you may come to me and say that, see, this is I want this kind of mission to actually do this kind of thing. It will help India to grow. If you come up with something, we may consider that also.
Sir, my last question is, what effort ISRO make to promote public awareness and understanding the space research and its significance?
So we have, okay, as suggested, me being in front of you itself is one answer for that. So like me, there are many people doing human service to take the ISRO missions, ISRO science and everything to the students and the common public and everywhere. We try to go to different forums, different places to talk about what ISRO is doing. In addition to that, ISRO has their own outreach program in all centers. For example, in headquarters, we have capacity building and outreach program office. So they take care of taking this to different strata through, as I mentioned, UVCA, START, or whatever other programs are. In addition to that, we actually have this National Space Day, which is on August 23rd, and National Science Day on February 28th. We conduct open sessions, and we go to different people, different villages, different places, and actually try to talk to them about what ISRO is, how they can reach, come to ISRO, and all sort of things. On February 28th, National Science Day, anybody can come to ISRO. It is an open day. All the centers are open for the people to interact with the scientists, and they can see the museum exhibition, all sort of things. Okay. In addition to that, most of our research, all the latest results are immediately published in the newspaper. So we are trying, and also now, okay, this is one important thing. The current chairman has initiated a 100-book writing program. So ISRO is school and college students, which will be covering various aspects of ISRO, all the science mission, all the communication missions, like all the things which is involved with ISRO. It will be available for all of you online, and each library in the entire nation is going to have a copy of. We would like to, whatever we know, to the public. This is one of the major things which I have started. The first book will be coming in a few months' time now. So we are planning to have totally minimum 100 books. Okay. So these are some of the major programs and others. In addition to that, we also have at a lower level. Now, when I say lower level, it is the lower level for ISRO, but at the basic level, many of the engineering colleges, we are allowing them to launch their own satellites. We give the complete technology and everything. We support them, how to build them, how to make them, how to actually get the data back, everything we do, and even we launch their missions. Some of them has come from Bangalore, some 2-3 colleges called Nitte College, and Chennai, some 2-3 engineering colleges have done. One completely women college called SRVM has actually, they have their own satellite. So if you have some idea, you can also build one satellite, and we are very happy to help you out in actually launching that. With all these things, we have a new platform. It's not a new platform, we have a new program called POEM. So you know that when we were talking about rockets, so the rocket, after it puts the satellite there, the leftover rocket, for all practical purpose, is a waste. It has nothing to do. So our former chairman decided, why not use that? Okay, so that is called as PSLV orbital module POEM. So that, since it's already there, with a minimal effort and minimal cost, we can actually provide the students and startup or people who are just starting a launch program at a very value for money cost, which will help you observe do observations from space for up to 3 months. So this is open for everybody. Anybody from India can write to us and ask for space on that. So like this, there are a lot of programs, and you will, if you log into our isro.gov.in, you can actually see all these things there listed. Okay.
Yes.
Good afternoon, sir. Sir, my question is that how and why brightness of sun reduced when there was more brightness of sun in 2001 compared to 2006?
So that depends on the number of sunspots that exist on the sun. If there are too many sunspots, but the variation is less than 1%. So it is not significant variation, but that 1% variation comes because if there are too many sunspots, it takes away the area and therefore it appears dull. But the variation is less than 1%. Remember that. Okay? Next way.
Okay. So I love to give homeworks. Sir mentioned about sunspots, sir mentioned about dimming, and sir mentioned about how the 11-year cycle, everything comes, everything. My simple question, and you can take this as a homework. Is sunspots good or bad for humans or life on earth? Can you just guess? Have you any time asked this question when we are talking about sunspots, dimming, the less intensity, all sort of things? Have you any time thought whether sunspots is good or bad for life on earth? Any guesses? There can be only two answers.
Let them answer. We'll answer that.
Only two answers, good or bad. How and why, I'll talk about later.
Bad, sir.
Bad. Why?
Sir, I may guess because it releases sun winds like solar winds, so it may cause what damage to the Earth's magnetic field. So
Good.
it is bad for humans.
Right. Life. I'm not talking about overall life. Any other guess? Any other guess? If somebody says bad, somebody should say good.
So I don't think it can have an effect. I believe it doesn't.
It does have an effect. In 1975, half of America's electricity grid was knocked off because of one flare, as you said. So it is bad. It is bad for our astronomy missions. Not only astronomy missions, space missions also, because it can destroy the satellite. So we will be we are actually trying to see whether we can predict that. We call it as solar weather. Whether we can predict that before it hits us. So it's not that it will not have any effect. It will have an effect. I have a video. You can actually all of you have mobiles. You can search for NASA Fiery Sun, FIER Sun, Fiery Sun. There they show a flare coming out of sun and falling back. It is a failed flare. But why I am mentioning is that loop, whatever it makes, that loop is big enough to put 10 Earths inside that. So that is the kind of matter a sun throws out. Okay, and the temperature of this is few tens of thousand Kelvin. You imagine that fast, that temper electron, and all of them are ions coming and hitting Earth. It can actually do lot of harm. It's not that it's not. So even then, okay. Sir is promised to answer this at the end. Till then, I'll just give a clue. Ice age. There is something called Maunder minima. You can think about in that term before sir answers. Okay.
Sir, I actually had 5 questions. So could I ask all of them together or at intervals?
Together.
Okay. So, sir, I don't remember what you in the first lecture. You said that if we magnify or zoom in after the atomic level, so what is the name of the particles that you explained?
Quarks. So, so each proton consists of 3 quarks, and they're called QUA RKS quarks.
So, sir, my question was: is it
Yeah. Go on.
so, my question was: is it possible that what we know from the smallest components, I thought it looked similar to the piece of universe that you showed at the farthest level that we
Yes.
can see. So, sir,
Because at intermediate, at lower levels of the level that you're talking about, you work with electromagnetism. That goes as gmm by r square. Gravity also goes by, electrostatic goes by q1, q2 by r square. The other one goes as m1, m2 by r square. It's only a question of constant of proportionality. In one case it is 1, the other case is 10 raised to minus 26. So at 26 orders of magnitude you get similar things. You don't get identical because in electricity you have repellent and attracting, while gravity is all attracting. So it looks similar but not identical. Okay?
so I had another question. There, you in the photo you showed, you said there are 2 tails of the comet. So why is that?
So 2 tails of the comet come from the fact that when the comet is traveling, it is evaporating a lot of dust, etc. That makes one tail. The second one comes from the radiation from the sun, which takes radially out. So the blue, if you remember the image, the blue tail was from the radiation from the sun. So the sun would have been in the light of the thing. While the other tail defines the direction of the comet because as it left out material, it traveled in that direction. That's how it has 2 tails. Okay?
Okay.
Shall we give others a chance to ask? Yes, the girl behind you wants to ask.
Good evening, sir. Sir, my question was that what goes in the process of making a new discovery, like whether it be in the field of aerospace, astrophysics, or atomic energy, and how can we students think and question passionately?
Um, so what goes into discovery partly is necessity is the mother of invention. So technological developments generally are defined by the necessity requirements. Okay. On the other hand, there are some discoveries that come serendipitously by chance. People didn't realize that this is how nature will behave. They keep on looking for what is happening and suddenly find some strange things happening. So a lot of discoveries in science are chance. Some of them were there because people are looking for it to try and. So, for example, the velocity of light discovery that it is constant came because people were actually trying to see whether Maxwell is right or Newton is right. So, some are driven by questions about what we think we know, some are driven by chance, and some are driven by specific requirements to do something. These are essentially the 3 ways.
Ah. So sir mentioned about chance discovery. All of you are aware of the most known chance discovery. Can anybody say that? It is very, very essential for us. Any idea? In medicine. In medicine. Penicillin. Penicillin.
How many of you know about penicillin?
Penicillin. Yes. Thank you. It's a chance discovery. And you know, the chance discovery happened by a scientist because he knew what to throw off and what to keep and what to work on, what to look for. So it is not necessary that the chance discovery will actually hit you, means you can actually become a discoverer unless and until you have knowledge of knowing whether useful or not. right? So don't just depend on chance all those times, because even if you are just in front of it, you may not realize that it is a discovery. To have that knowledge, you have to study well and know the things.
I mean, there are only few ways. One option is going deeper, deeper, and deeper, asking why. All right. And eventually it will boil down to a level that I understand this phenomena pretty well. All right. And these are the things responsible. Once you have gone to that level, then the next stage is predicting that if I have a similar situation or slightly different situation, what will happen. So if your model is correct, if your understanding is correct, if you have factored in all the parameters that affect it, all right, then it will be all right. And mostly 80-90% it will work. Then somebody will walk out with one day. For example, that one this particle which came back in Rutherford experiment. Why one came back? Most of them were going straight. You could have easily said fine, but the real model depended on that. That yes, one is coming back. So what is that? And once you have such a discovery that no, it's not fitting the known picture, then you have a discovery. Okay, so as I told, Fermi said that if you are making a measurement which conforms to a hypothesis, you have just made one more measurement. There were 99, you have made them 100. But if you make one observation which is not fitting the hypothesis, then you have a discovery.
And there's no advance way of telling what will happen.
And also, it's not that all the discoveries are positive only. Sometimes negative results can also become a discovery. One of the best example is the failure to identify ether going around, which was assumed to be surrounding Earth. That actually pave way to even velocity of light.
Yeah. So what happened was that nobody liked Einstein, nobody liked Maxwell because too much of mathematical work. So they were all very keen on proving Newton was right and Maxwell was wrong. So they did a lot of elaborate experiments to try and convince everybody that Newton is right. It didn't succeed. All those, like the famous Michelson-Morley experiment, did not succeed, and the velocity of light turned out to be the great universal constant. It is the only negative experiment that has won a Nobel Prize, where the experiment failed to prove what it set out to prove, but it changed the world.
That became a success.
So yes, exactly. Next question.
Sir, good afternoon, sir. Sir, my question is for Rajesh, sir. Sir, as you told yesterday that radioactive elements emit radiation, so like that, using the principle, Marie Curie discovered X-rays. So, are X-rays harmful for human body?
No. Marie Curie did not discover X-rays. X-rays were discovered by Röntgen. Okay, and there is a difference between X-rays and gamma rays, as Mank sir also told. First is in terms of energy. Usually those are MeVs and these are in keVs. And secondly, source. So we say X-rays when it is basically from an electron jump. Okay, an outer electron going into inner electron and leaving its energy. So that is X-rays. X-rays are not harmful. We are often undertaking X-rays of chest, this and all these things. X-ray is like a burst of photon which has gone away from you. Continuous exposure to high energy radiation is harmful. You should not be continuously exposed. So there is always some threshold. These many millirad, this. Okay, you should always be below that. That is what it is. Okay.
Okay, sir. Thank you, sir.
Questions here? No, here, down here. Then there's that girl who wants to ask a question. We would like to ask, give chance to people who have not been asking so far. Yes.
Good afternoon, sir. Sir, my question is, as you said that satellites become debris after the work is over, so that can cause problems in future rocket launches. Sir, how can this problem be solved?
So there are many ways to actually trying to mitigate this problem. People are trying to push it down so that they enter the atmosphere and burn out. And some people are trying to actually capture and same way bring it down so that it will burn out. And there is something called grave. We know graveyard, right? Where all the dead people are left. Something like that. There is a graveyard orbit, which is slightly above. For example, if we are considering low Earth orbit, around if it goes to push to 800 to 900 kilometers, that place the satellites will keep on rotating for hundreds of years without falling down. So but the people are trying to push into that graveyard so that they stay there without breaking. So reducing the this one. And then nowadays there people are experimenting on new material and even wood to see whether it easily breaks out and it is easily burns out without leaving anything there. So the people are working on that. Still we have not reached to the level where we can actually remove all the debris. As of today, we have to live with that.
Good afternoon, sir. Sir, we do know about the Big Bang theory. So, are there any other theories like this which tell us how the universe might have started?
No, so there were two ideas at the beginning. One was the Big Bang, you know, and the other was that maybe the universe has always existed like this. It was called the steady state theory. And for until about 1920s and 1930s, actually, till well into 1950s, if we were not sure as to which was the exactly correct theory because of the way of circumventing things. Eventually, when microwave background radiation measurements, when the temperature of the universe was measured, it turned out to be exactly as predicted by Big Bang. And there were other models, other predictions that Big Bang theory made. Like he said, if you know good theory, if you work to it, you should make predictions and check. And all those checks held out, and that is why eventually steady state theory is not what people study anymore. So there are ideas that change. There's a girl at the back who wants to ask in blue t-shirt. Yes, I'll give you the next chance. I don't know.
Good afternoon, sir. Sir, I would like to ask how do we get the idea to go to outer space?
How, I mean, it's an obvious idea. No, if you go to aircraft, you might as well go to outer space, and
No,
then you realize the advantages of going to outer space. Okay.
Sir, sir, how do we get to know all the planets and
That's a long story. You should have attended my lecture in the afternoon. It's a very long story. I can't really take it up just now. Yes, can you give it to next? Yeah, and then we come
Good
here.
afternoon, sir. So my question is that when an asteroid comes, like how the scientists are giving its name, and sometimes the asteroids are changing its direction from hitting the Earth. Is that because of an external force that is pulling away it from its way?
The only force active at that size scale is gravity. There is nothing else. And initial condition. What is exactly the direction in which you, if you are pointed straight to a gravity housing, you will go and bang into it. If it is at an angle, you will turn. So it's a question of initial condition and gravity, as far as trajectories are concerned. As far as naming is concerned, there is something called International Union of IAA, International Astronomical Union, which is a body of all astronomers from all over the world. And their general body decides and their committees decide how to name which object in which way. Generally for minor bodies it is just the year of discovery and the sequence number. For other objects there are privileges. So there is a Homi Bhabha crater on the moon, etc. That is decided by a common committee.
Thank you, sir.
Welcome. Here the request.
And sometimes it so happens that the discoverer will get a privilege to name it with some constraint. So some of the things he cannot name, but he can name it.
Especially in minor bodies.
Minor bodies. See, for example, that Hadama, what is the latest one? Starting with the one which was supposed to be coming from aliens, starting with H. So the recent one is like that, named like that.
So good afternoon, sir. Sir, my question is why returning human to the moon is important when we already have satellites and robots?
Okay. So yesterday I tried to answer this day before yesterday. The reason the man did not go for 50 plus years is because robots and the missions can do better job than humans at a nominal cost, less cost. But now since we know that water is there on moon, now our next step is to see whether we can actually build a flat there. So if you want to habitate that, you have to actually study. A machine cannot do all the studies or all the effects of whatever might happen by staying on the moon. So to study all those things, you need somebody to go there and actually do that. Hence we are going back again. Till then now we have given it up.
Sir, my another one question. Sir, as in the first day, as you have said that Albert Einstein stated that it is impossible for time travel, but Stephen Hawking said that time travel is possible.
No. He never said time travel is possible.
Sir, I have googled it in today.
Exactly what were his wordings?
Sir, I searched that is Stephen Hawking agree with the time travel? Then it is said yes.
Because I'm Stephen Hawking. There is no way Stephen Hawking. He would have imagined if time travel. So he has done various theories about how time works. But reversing time and going back into time, Einstein is very clear. You cannot do it.
Sir, one last question. That how do scientists detect black hole if light cannot escape from it?
From the material that is falling into the black hole, leaves you a signature saying I'm falling into a black hole. Only by material falling into a black hole you can make out that there is a black hole. Isolated black holes cannot be seen.
Okay, sir. Thank you, sir.
So it's indirectly. Okay. So how they do is, as sir mentioned, when the material starts falling, they gets heated up. Okay, because it will not directly fall, it goes around and round. When they are going round and round, Kepler's laws, you remember, the one closer will be moving faster than the one slightly away. So that means the two layers will be rubbing each other. This rubbing actually creates, when you rub, what happens?
Frictions, heat produce.
Heat produced. This heat will reach to so high that millions of kelvins, they actually start giving out X-rays. By actually seeing the signatures of these X-rays and studying the characteristics of these X-rays, we can actually make a assumption on what should be the mass and what should be the other features. Based on that, we can say that there is a black hole or not.
Okay,
Indirectly.
Thank you, sir. Good afternoon, sir. My question is that what will happen if two congruent black hole will come next to next?
There you simply add their mass and you get a new black hole twice the sum of the mass. It's a linear addition of masses. 5 million solar mass star black hole meeting with a 3 million solar mass black hole will give you an 8 solar mass black hole. Nothing very dramatic happens.
Sir,
We have seen it, yeah.
sir, if they are congruent, then their gravitational pull must be the same.
Yeah, though they're stronger. By पहले 5 million solar mass का था, अभी 8 million solar mass का हो जाएगा. So it will just become stronger.
So there must be a point where the net force becomes zero.
No, it increases. Mass increases, so the force increases. You mean you want to keep two black holes opposite each other, and whether
Yes,
there will be a Lagrangian point between black holes also.
Okay.
That will be.
So my next question there, so why ISRO is not making rockets totally of carbon fiber? So that the rocket will the rockets have less weight and it can go more faster.
Okay, that's a good idea. But now you know that when I was showing that rocket, we put a heat shield on top of that. Heat shield is nothing but whatever the ceramic and others, because when you are going outside at very, very high speed of say a few kilometers per second, the heat generated is so enormous, it has to withstand that heat. So the carbon fiber may not melt, but it will deform. So if that happens, then everything will collapse. The direction will change or something will happen. So we have to look into all sort of these things to make sure that none of them happens. See, what is happening is there is a nozzle in the back which is actually controlling like where the rocket will go. Assume that I made that nozzle with carbon fiber to reduce weight. So this is almost at few thousand degrees centigrade. If the nozzle breaks up, what will happen? Everywhere. We will not even know. It will become a Diwali rocket where it can go anywhere.
So can we make an alloy with carbon fiber?
So people are trying. Metallurgists are trying to make heavier, harder metals. As of now.
No, which have to actually survive all these extreme conditions.
So with titanium?
No. Each metal has its own set of problems and solutions. You cannot use a single metal. Titanium is also very expensive. But anyway.
Titanium, you are going against your own suggestion, because titanium is a very, very heavy metal.
But believe me, metallurgists are really working hard to get.
Even saving 1 gram will save us 10,000 rupees.
Yes, exactly. Yes,
Sir,
please.
sir, one more question.
Yes.
Sir, in next 50 years, what is ISRO planning to decrease the friction in the rocket by using some lubricating substances?
It's aerodynamics working in 2 minutes time scale. So essentially, it is a conical shape that works, and it is not going to be in atmosphere for a long time. So putting a lubricant outside will not solve the problem. It's only a question of having geometry. It will simply wash.
See, if you are actually traveling in a car at say some 60 to 80 kilometers per hour in rainy season, you can see that water will look like it
glass windshield. Simply
That
go.
is only 50 to 80 kilometers per hour. I am talking about 6 into 3600, something like 20,000 kilometers per hour. At that time, what will happen to that? It will simply evaporate. So
Yes.
this one won't.
Thank you,
You.
sir.
So my question is, can you explain about the concept of warp drive?
Warp drive. Warp drives are science fiction imaginations of people. It is a storytelling. There is no such thing as a warp drive. Jet engines are the best engines we have.
And about Kaluja-Klein theory?
Huh?
Kaluja-Klein theory about five
About?
dimension.
Oh, so what has happened is, sorry. So there is a story called Flatland, where everybody is two-dimensional. Okay, so some people are like triangle, some people are like square, and they see a sphere going through their plane. So what they see is they see a dot, and that expands into a circle and then goes back into dot again. They just can't understand. But if they define a third dimension, then everything becomes clear. Similarly, the way that universe that we have today in 4 dimension, we are struggling to understand everything. So people have tried to wonder if we go to 5 dimensions or 6 or even up to 9 dimensions, whether we can understand things. But there are no good theories at higher dimensions. So far as we know, 4 dimensions is what we have. Any other questions?
Sir, what is the difference between string theory and E8 theory?
Oh, those are profound. One of them assumes that the finest particles are like strings, and therefore the string expansion, string, etc., contraction, etc. works. The quantum, which is the other theory you said? Huh?
E8 theory.
EA is? What is EA? Okay, so there are various ideas of what happens to the universe below 10 raised to minus 18 that we have did. None of them have predicted things which we have experimentally tested. So we have really no idea what happens below 10 raised to minus 16 meters. Yes, next question. This side, yeah. That girl has a question. Yeah, quick.
Good afternoon, sir. This question is to Rajesh, sir. So yesterday I have seen that ultraviolet rays that was written that ki paper soaked in AgCl solution, and there we can found the ultraviolet rays. Can we use any other sort of solution rather than AgCl solution?
You can use anything. Okay. He was trained in photography and that was the easiest he could get. And the whole thing that I was trying to impress upon you is a simple idea can give rise to such a big discovery. And that he just took a paper and he found, yes, there are rays, though he was initially looking for thermometer. But because ultraviolet rays do not have this heating capacity, so, but his logic was correct. The question was, how can it be that only on one side there are rays? There have to be on the other side. And he did not realize that they can be high energy. And this high energy has to be now tested because they can induce chemical reaction. And because there is high energy, the chemical reaction can be induced faster. So what was happening in blue region maybe over 1 minute was happening in ultraviolet region in much less time. That's why. All right. So the idea was that simple ideas can lead to great discoveries. Just a thermometer and complete infrared. Can you do some research today using thermometer? Not possible. Yeah. Yeah.
Sir, one more question.
Please.
Another question. Sir, Mayank sir. Sir, you have shown that slide that in that graph there is Fermi gas. And what does that gas?
Fermi gas, I didn't show you anything about Fermi gas.
Yeah, in that morning session, you have shown that graph. There was something written there.
Not for. I don't know where I refer to Fermi. Fermi gas.
Yeah. That was something written so long. I just remember Fermi gas.
No. I don't think it was Fermi gas. I think it was about. No, you'll have to give me a better reference. I don't remember where I said. You think about it. What is? We'll take other questions right now. You tell me exactly where it was. That girl also has a question. That girl with specs. Here.
Good afternoon, sir. My question is to you is space related sector different from astronomy sector?
Oh, astronomy. Okay, so there are two completely different fields called astronomy and space sciences. We are cousins, but we are not brothers. Okay, space sciences involve use of space, rockets, technologies, and use of space for improving our understanding and our life. Okay, So Girish is unusual, but otherwise most of the ISRO scientists will not be able to tell you a constellation in the sky because it is not of their, it is not their problem. On the other end, if you tell me how a rocket is designed, I can't do it. Okay, I am an astronomer. He is a space techno scientist.
Astronomy existed much before space science came into tech.
Yes, that is also true.
Sir, my another question is, by becoming scientist, how can I serve purely in military sector?
So whatever you're talking about drones, whatever you're talking about intercepting, whatever even the communication, cyber attacks, and then what should we say? That cyber security and breaking ciphers. There are, you can say anything, even biology, and more than anything, even you can start at the lowest level, how to keep the soldiers healthy with minimal of food or minimal medicine, how to keep their teeth for not falling off, they keep them warm, and you can actually make some clothes which can keep them warm in Siachen, help them from frostbite. I can talk about many things, including mathematics, because they should actually identify, if I launch this rocket from this position, and if I move this rocket launcher from this position to that position, what are the angles I have to change so that it can actually reach the target. Mathematics is required. Biology is required to actually make sure that everything is working. Medicine is required. Chemistry is required to make sure that whatever the weapons they are creating, whatever the explosive they are making using will not explode in their own hands. It will wait for the reach this one. So almost every field, you tell me a single field, I will tell you where it is useful. Even civil, you will be forced to actually construct bridges within short time so that there is a movement. Okay, so
Thank you, sir.
yeah.
I remembered you were talking about Fermi. I think it was about Fermi degeneracy is the phrase I'd used. So, exactly. So what happens is that there are two kinds of particles. Okay, by some arbitrary measure we say one of them is half and the other one is one. Now half particles have a different kind of property than one particles. Okay, one particles are called bosons. Half particles are called electrons and other particles. And those half particles are called fermions. And those fermions have a property that no two fermions are friends. They can never be in identical position. So if one is up, the other one has to be down. So in a collection, if you collect bosons, they can all be in the same state together as good friends. Fermions will not be. So if you have too many fermions, they will automatically increase the volume and not allow many things to happen. In that context, I had used Fermi. It was Fermi degeneracy.
To answer your question, I mean, a war has only two goals. Number one is maximum damage to the enemy and maximum protection to self. These are the only two goals, right? So you go into the history of World War I and World War II, you will be surprised to know the maximum good science or destructive science has been done during at that time. For example, if a German aircraft started, all right, what time it is coming, where it will reach, how can we intercept it, all this was developed at that time. All right, you go to Second World War, lot of dirty chemicals. Even the entire atom bomb, so-called Manhattan Project, was done secretly in America during that time. Okay, so these are, and because of that, though, I mean, these two bombs which exploded, fat man and little boy, they killed a lot of people. I mean, roughly like 1 lakh at each place. However, probably it stopped many more, because had the war continued, okay, we would have lost many more. So science is everywhere, and you will find that in First World War and Second World War, most of the scientists were there. In fact, when and this First World War was going on, most of the atomic physicists, they were put somewhere or the other to help military people to either, let's say, unlock some secret. They were sending messages, Morse code, all these things around that time. Okay, just see scientists in the world wars. You will see a lot of material.
Okay, next question. The boy at the right at the back. Huh?
Sir,
Okay.
I have a question in mechanics. Can I?
Yes.
Sir, the mechanisms and technologies used in clocks and watches, are they useful for any other purposes other than time?
No. So, for example, these days watches do more than have time. Okay, my watch tells me what is my heart rate and how many steps I have walked. So watches have become very versatile. The periodic timing is used for defining a lot of parameters. How long your microwave will work is also done by it is called a clock, but essentially it is the same ticking mechanism. So that periodic oscillation mechanism is used at a lot of places for a lot of kind of thing. How long your phone will remain bright will also be decided by the number of ticks in a particular crystal.
Yes, sir.
Okay, so time is oscillations are a very general set of terms. Any other question?
Thank you, sir.
There's a boy at the back right there. Yeah, yes. Tell me.
So my question is, what are the similarities and dissimilarities between the subatomic world and the extraterrestrial world?
Oh, extraterrestrial worlds are just globes like Mercury, Venus, Mars, Earth, planets, etc., etc. Subatomic world is a completely different entity. They don't even mix. Extraterrestrial worlds are places like planets at other places. And so I don't even think I fully understand your question. And subatomic world is subatomic world.
Okay. So there's not any similarities.
No,
or
no.
something. Okay. So I had one more question. Like, do planets and stars really does an impact on us as the astrologers give us
No.
gemstone?
Please, please don't believe anything in astrology or anybody who makes any kind of predictions. These things have been tried and tested. So there are two ways of doing science. One is that any knowledge is an extension of the current knowledge, and the second thing is any unusual prediction of completely something very different. In either case, the test that people use is that reproducible. You should be able to reproduce what you've done, and equally important, you should be able to explain how it is done and why it is done. And the third is whether it is valid or not. Astrology fails completely on the grounds of statistics. Okay, most of them are suit talkers. So please do not believe in astrology at all. Second thing is there is no physical reason. Okay, a star is at least the closest star is 4 light years away. There is no way I was not even conceived until 9 months before I was born. Okay, so the star 4 light years away could not have sent light 4 years ago with a particular manipulation to change my life on Earth. Okay, that star doesn't even know I exist. Even planets. Right now, as I'm sitting here, the railway train that is going by the platform nearby has more gravitational effect on me than Mercury or Mars or Venus or Jupiter will have, because the force falls by 1 by r square. Okay, and these are astronomical distances. And again, the planet is never where they say it is when I'm born, because the planets move. So it is neither scientifically accurate. It does not explain why it happens. It does not explain how it happens, and it fails on statistics. Okay. On the other hand, we are all anxious about future. If somebody tells us that good things are going to happen to you in future, I'm willing to pay money for it. But at the end of the day, there is no scientific validity to that. So please do not believe in any fortune telling of any form. Palmistry se leke astrology tak. Okay.
So, but sometimes they are correct. No?
So there is always a statistical chance. Okay. If I'm hereby predicting that 10 of you will fall on the ground before tomorrow evening. One of you will fall by sheer chance. Okay. But I will only tell you about the one fellow who fell, saying that I had predicted and he fell. The other 9 did not fall is something I will not tell you. So this is wholesale cheatery.
So let me actually continue on that. So assume that I have predicted that next week you are going to die. What are the possibilities? Either you will die or you won't die. So if you don't die, then that means that whatever my prediction is wrong. Starting with everything is gone. If you die, what are you going to gain? You lost this week also. Just thinking about that I am going to die, you are going to die. So what exactly is the use of that? Then coming back to actual answering the other question, there is a famous scientist from Sri Lanka called Professor Abraham Kovur. So please read about him. 25 years back, he set up a award saying that at that time, 25 years back, 1 lakh rupees was the prize money. So the simple tasks, 3 tasks, one of them corresponds to astrology. I will give you exact time and date and everything of the person who is born. Statistically significantly, out of those 10 or 20 people, you have to predict better than 50% chance. Sir said about choice, na? Better than 50%, whether it is a man or woman or whether they are alive or dead. Simplest things. If a person can tell you what is going to happen tomorrow, he should know whether the person is already dead or alive, whether it's a man or woman. For now it is almost like 50 plus years, nobody has claimed that money. That should tell you something. Okay, then Sir's talked about the nearest, this one he can give you. See, Indian astrologers or Indian, everywhere, they use two things. India, it is stars or planets, and in other than zodiacs. Zodiacs never is an Indian idea. It came from Greeks only 2000 years back. 1500 years back. Okay, so at that time, whatever the months they defined that this zodiac belongs to, that was never changed. How many of you play top buguri, what we call it as top in Hindi? Not two. How many of you played that? So there you know that the top not only turns like this, it actually makes this motion. Our earth is also exactly doing the same. So that means that earlier, say in 1500 years back, when, okay, before that, I want to ask you, how do you know which zodiac you belong to? How many of you know, how do you actually find out which zodiacs you belong to?
Sir, we Google it or the astrologer or something.
Actually, physically, the way you have to do is when the sun is rising at the horizon, whatever is behind that, exactly in the same line, supposed to be your zodiac. What happens is when the sun rises, there is no zodiac. So you can't actually find out. So you are still sticking to the same, whatever astrologers have said 1500 years back, now it is actually off by 2 months. Even if the prediction is exactly, Sir Mayank Vahia sir is actually predicting you 100% perfect, it will not apply to you, it will apply to the person.
I'll give you a concrete example. We have Makar Sankranti on 17th of January or something. 14th of January, okay? Makar Sankranti is also celebrated as Uttarayan, that the sun starts its northward journey. The Uttarayan happened on Makar Sankranti in 500 AD. Today, Uttarayan happens on 21st of December. 3 weeks off. Okay, but astrologers still continue with Uttarayan and Makar Sankranti on 14th of January. So their methods are ill-informed, their methods are not correct, they're statistically not valid. They're just pulling a fast one. They are very good soothsayers, they're very good psychologists, but nothing more than that.
Okay, so then coming to the planets, Navagraha. So if you consider Navagraha, Sun and Moon are not grahas in the term of planets. Okay, Rahu and Ketu are not even physical entities. So these people never knew about the bigger planets like Uranus and Neptune. So you are starting with any of your thing with 50% wrong assumption. What is the chance of getting your thing's final prediction correct? So I hope.
Yeah. So basically, don't take it serious. Then let somebody ask another question.
Sir, one last question, sir. So, in coming future, will it be possible to escape from Milky Way galaxy?
Not within foreseeable future, because okay, I will tell you what if the first human being had left the Earth, that was born on Earth 1 million years ago, had sent up a GSLV would not have reached even the nearest star today, a million years later. Okay, so the astronomical size scales are simply enormously large.
I just mentioned about Voyager. It left 50 years back. It hasn't even covered one light day. We are talking about years.
We are talking about 30,000 light years. Yes. Give him the yes.
1 minute, sir. Good afternoon, sir. Actually, I was curious about this question from the very first day as you attend the session. As the science does not believe in any kind of paranormal activities and completely rejects the astronomy.
Correct.
Then I just wanted to know what are your personal views on telekinesis?
Nonsense.
Okay, next.
Is that really?
Yes.
We'll take it up later.
Yeah.
Actually, sir, during my engineering days, I was doing an experiment
Can we please take it up personally after this?
1-to-1.
Okay,
Let
sir.
others ask questions.
Sir, as you said, time travel is not possible. Then what is a wormhole based on Einstein general theory of relativity?
There is no wormhole based on general theory of relativity. Wormhole is an idea of science fiction writers, under the visualization that if a black hole creates a well in space time, whether it can be connected somewhere else or that the matter falls into a black hole will come out from somewhere else. It's complete total fiction. Okay, there is no such thing as wormholes because the so-called hole that black hole creates is actually a three-dimensional object. So it doesn't go and connect somewhere else. The space-time is not a plane which is warped or something. So those are not scientifically valid concepts. There are no wormholes. We have never seen in the whole universe anywhere where material comes out from nowhere. Okay, so please don't believe in wormholes.
So another question. Why is the sky dark at night even though the universe has billions of stars?
Sorry?
Why is the sky
All
dark?
those paradox. I'm going to ask you to ask AI for that. It's a straightforward explanation. Okay, huh?
Good afternoon, sir. My question is to Rajesh, sir. Sir, why is the Raman effect so weak compared to normal scattering, even though all molecules are interacting with light?
A good question, I must say. See, in Raman's spectroscopy, what we are doing is we are using a photon in the visible region. That means you saw 488, which was bluish green and all these things. And the light is not absorbed by the molecule. So this photon, if you see the quantum picture, this photon spends very little time with the electron cloud of the molecule. Take for example the cyclohexane or even simple methane. Okay, so methane has this carbon, hydrogen, and there is an electron cloud, So we call it electron cloud. It spends a very little time, and this time is of the order of 10 to power minus 16 or even less. All right. In that time, the entire cloud either has to vibrate in such a way to give rise to either absorb one or give its own energy to the photon. So this second process is very difficult. Quite possibly, it may so happen that when the electron cloud is moving inside, it may pick up some energy. Okay. So as this time scale of this process is so small, the probability reduces very, very drastically. Most of the scattering processes, the cross sections are of the order of 10 to power minus 50, 18 centimeters square. That's the number we use, but I didn't want to confuse you with these numbers. Yeah. Anything else?
So my second question is about astronomy. Could dark energy be a sign that our understanding of gravity is incomplete rather than a new form of force?
Yeah, so there is something called Occam razor in science, that in any number, any theory, the number of assumptions should not be so much that the theory becomes invalid. And if you have multiple choices, take the simplest theory. There are alternatives to dark energy, saying that gravity becomes weaker, etc., etc., etc. Unfortunately, their experimental predictions have not come true. And we have had no, and the simplest theory is to talk about dark energy rather than weakening gravity and all that, because people who have suggested weakening gravity on this size scale, etc., have made predictions which have not come true. It's simple as that. Okay?
Yes.
Yes, you had a question.
Good afternoon, sir. Sir, you previously answered my question about why sun expands then becomes the white dwarf. My question is that you also said that red giants and other compress into neutron stars. Why doesn't they also expand and then turn white dwarfs?
Sir might not have actually told that. So the normal star with mass less than 2 solar mass will first expand and become red giant, and then the outer layer will be thrown out. Inner core, since there is nothing actually giving out the energy, it will compact till electron degenerate pressure, that is the Fermi degenerate pressure, takes over. In the other, if the mass is more than 2 solar mass, even this electron degenerate pressure cannot help it. So this will expand much more. It is called as a red giant. Super giant. Okay, that will be bigger than whatever the red giant which is actually going to happen. For example, if our sun becomes red giant, he can cover Mercury and almost reach up to Venus. But if a higher massive star actually becomes a red giant, he can even cover Earth and move almost up to Saturn, depending on the mass. So it is super giant, much bigger than red giant. Then after some time, even that will be thrown out. Remaining core will actually start falling again. Sir might have not told this because he might have stopped at a white dwarf, but these things will starts collapsing. when they start collapsing, as the is collapsing, the electrons will start gaining more and more energy. The electrons will start fusing into the protons to become neutrons. So two things are happening. One, total mass is more, gravity is more. At the same time, electrons which were stopping it is also reducing faster. So it will start falling faster and faster and faster till suddenly neutrons also are polyons, that is half spin particles. They will also say that no, please don't compress me more than this. Keep your distance. That is called as neutron degenerate pressure. That suddenly, like a ball, if you take a ball and throw at the wall, the ball will keep on going till it sees the wall. Suddenly it bounces back. At that time, this entire outer layer is thrown out. That he might have mentioned as supernova. So it happens in that time also. It's not only in the white dwarf stage. Neutron stars are formed like that.
Sir,
Did I answer your question?
Sir?
Did I answer your question? Okay.
Sir, I have another question. I have heard terms like red dwarf and black dwarf. Does that really exist or they are just rumors?
Sorry?
I have heard terms like red dwarfs and black dwarfs.
I don't know about red dwarf. Black dwarf, when I say white dwarf is at very, very hot temperature, something like 25 to 30,000 degrees centigrade or Kelvin. So they will have only heat as the source. So when it is giving out its energy, it is cooling down. That means that at some point it will lose almost all its energy so that it will become black dwarf. But the time required is so high that it is more than the total our age of the universe. Hence, we don't see any black dwarfs, except in theory.
Yeah, just one more. There are also something called brown dwarfs, which are very small stars, just bigger than 10 times bigger than Jupiter, but not big enough to become a big star. Those have their emissions in red and infrared, and they are also called brown dwarfs. So there are two kinds of objects which are called brown dwarfs. Yeah, red dwarfs is essentially the same thing, cooling down. Huh?
Sir, I have another.
But, let somebody else ask a question.
Okay,
You can't
thank you,
come
sir.
back. That boy wants a question. Just a minute. Bolo. Ask.
Sir, I have 3 questions. Shall I ask?
Then let us take, because he has never asked a question. Ask a question.
So my question is on gravity. Like we have 4 fundamental forces. The strong nuclear force has gluon as its force carriers. Electromagnetism has photons, and like similarly, weak nuclear has W bosons. So what does gravity have?
Gravitons.
What are its characteristics?
So gravitons are again massless because the force goes to infinity. Its spin, I think, is half. I don't remember. But it is again a virtual particle that is exchanged between objects at gravity. But because like electromagnetic force can also go to infinity, gravitational force can also go to infinity, so it has to be massless. Okay?
So my last question. Higgs field is responsible for providing mass to every particles. So what's the work of Higgs boson?
No. So I will tell you what, this is a misunderstanding in statement. Imagine you have lived under water all the time, and you have no clue why there is resistance to your movement, etc. And then you come across a heater by which you can isolate a water molecule. Okay? Higgs boson is like that water molecule. It is prevalent, it is everywhere, it resists your motion and everything. But now we have found the water molecule equivalent for matter in general. So now we will be able to study that what actually gives us the force. So Higgs boson producing resistance to motion, which is equivalent to mass, is everywhere. It is just that now we have been able to isolate it by heating up the local medium in the CERN accelerator, so that we know what that Higgs boson looks like. Okay? Next question. Wait a minute. You asked many questions. Anybody else? That last person.
Good afternoon, sir. My question is that why the color of sun is yellow?
It's temperature. It's strictly dependent on temperature. It is temperature about 5,500 degrees Kelvin, and therefore it peaks at optical light. That, in fact, the question is not why the sun's light is yellow. Stars have various colors. It is just that we human beings live on a planet which is close to the sun, and sun emits in optical wavelength, so our eyes are sensitive to optical wavelength. Okay? The sun was not designed as per our eyesight. Our eyesight was decided as per the sun. So stars of various temperatures will give you various colored lights, all the way from UV to infrared. We happen to live in a planet where optical light is the maximum from the star, so we see yellow color. It's just a question of surface temperature of the star, and surface temperature of the star comes from the size of the star. Okay, so if there was another civilization living next to a star which is say 5 times the size of the sun, they will see ultraviolet light.
And sir, how supernova galaxy are formed?
So there is no such thing as supernova galaxy. Supernova is a separate thing, like he said. It's an explosion of a star that has run out of fuel. And galaxy is a galaxy. It's a collection of a billion stars, trillion stars actually, 1,000 billion stars. Okay.
Thank you, sir.
Who else has a question? Yeah, he has a question. Give him the question then. Where? Give it to her then. Boss, give it to her. Yeah, never ask.
Good afternoon, sir. My question is why all the planets have different Earth days?
Because they are at different distances from the sun. Kepler's law gravity will tell you. Force goes as mm by r square. So the further away you are, the weaker is the gravity, and therefore the Kepler velocity is lower, so you go slower. Okay? Are you talking about revolution or rotation?
Talking about rotation.
If you're talking about day, then it depends on the initial condition about how the planet was formed. It varies from planet to planet, because each planet, in the final sum of things, you have an object in which other things are falling. So if a lot of things fall at an angle, you will spin faster. If a lot of things fall vertically, you will spin slower. So that's a question of initial condition. How exactly it formed? There's a boy that had a question there. There's a boy there. Here.
So I have a question that why would never use the Nikola Tesla's free electricity project?
Sorry?
Nikola Tesla free electricity project.
What is that free electricity project?
He made a documentary that he project that to make a free electricity.
How?
Using some magnet's repulsion.
No, I'm sure the technology had some flaws because I've never heard of it. If it was free available in electricity, I would love to produce it. Do you have an idea?
Look, you want to produce some energy, right? And energy is conserved. So you have to have something else giving you that energy multiplied by the efficiency. All right. So it will not be straight away that you use 100 watts somewhere and you will get 100 watt output. No, even that doesn't exist. You will get 20, 30 watts. So there has to be something which is working for it in order to produce energy. It can't be just free electricity available. Yeah. Anything else?
No. So there was somebody at the back who, he had a question.
Sir, I wanted to ask that what is the difference between geosynchronous and geostationary?
See, geostationary is an orbit where the Earth sees the satellite. Satellite is stationary on that. It sees that. So for that to happen, we have to have a synchronous before that. That means this rotation should be equal to the revolution. So that's the only difference. But for all practical purposes, it's at the same distance. That is 6,000 kilometers. It's the same. Both are same.
Synchronous means synchronized with the movement of the earth, and stationary means stationary with respect to earth. It's essentially the same thing. Yes. Other questions? There are some questions here. They have exhausted.
Good evening, sir. My question is, can we escape from black holes? If no, then how can we know that what is inside the black hole?
We can't. We cannot and we can't.
So at the end of everything, you just repeat this question to me. I'll tell a story to make you understand.
You cannot escape a black hole, and therefore you cannot know what is inside a black hole.
My second question, other than IISTs, which other institution can help us to join in ISRO?
Do graduate from a good college in any of the fields that ISRO wants and apply at ISRO. Anyway, so you tell them.
I have already told them.
Yeah.
we actually do not actually say that this is a college from which we I'm going to pick the people. See, what happens is I'll tell you only one thing, that because whenever ISRO advertises something, we'll get many more times, like orders of magnitude more applications than we require. For 100 people, 100 posts, we might get some 1,000 to 5,000. So we have to filter it. So the only filtering we use is the person should have first class. Other than that, we will not see which state, which area, which college, we will not see that. So again, there will be other exams and everything, but this is the basic criteria we use as a first class, just because to make sure that we reduce our workload. Nothing more than that.
Next question. Yes, he has a question just behind you.
Sir, what is Van Allen belt?
Van Allen belt is, so what happened is that, sit down there. Earth has a magnetic field. I don't know, have you done that magnetic experiment by which you put magnet and iron filings and this thing? Have you done that experiment in the school? Van Allen belts are those magnetic filing for the Earth, basically. Okay? Van Allen belts are the ones along which the magnetic lines of force move.
Sir, I have another question. What is length contraction?
That I told you, when I showed you special theory of relativity, I said delta L becomes L upon 1 minus V square by C square square root. That is length contraction. Because the length becomes smaller, you will look smaller to me the faster you move with respect to me. Okay?
Sir,
Yes.
last question. Sir, just like our solar system is in our Milky Way galaxy, and our Milky Way galaxy is in the universe, so is there any end to it, or it just keeps going on?
No, the large scale structure of the universe is the large scale structure of the universe. So that universe is not in another universe as far as we know. Yes.
So my question is, why doesn't galaxy expand along with the universe if space itself is expanding?
Okay. So you go home from school, right? When you go home from school, all of you run away from each other to their respective homes. But your shirts and your pants and your bags don't. Okay? They come with you. Exactly the same way what is gravitationally bound will remain gravitationally bound. But between the two objects, the space is expanding. So each of them will go away from the other. So this dark energy is not going to make solar system break. And it will probably not even make Milky Way break. But it will make Andromeda and Milky Way distances larger. That's all. Okay? Any other question? There's one question here. Udhar bhi hai kya kuch? Just, sorry, just one. I'll just give you a question. Yes.
So in the morning session, you have mentioned about nanoflares. So what exactly they are?
Nanoflares are very small flares which are not easy to see, but they contribute to the heating of the corona.
Sun's respective.
There are small flares on the sun which contribute to the heating of the corona.
Why do they are nano only?
Because there's a small.
Very small.
Yeah. Yeah. Okay. There are two girls there who have a question. Yeah, one in the white t-shirt first.
Sir, as we all know that Chandrayaan 3 landed on the south pole of the moon. But why is it considered so difficult to manage how the satellites are landing on the far places which never faces our Earth?
You mean to say the far side?
Yes.
One thing is, mainly the question will be like communication, because to have communication with the one which is landing on the far side, we have to have another satellite. It's difficult, but it's not impossible. China's Chang'e 5 actually landed on the far side. Humans did do that, but compared to the usage and whatever the benefits from that is less than whatever the problems we go through.
Thank you, sir.
Good afternoon, sir. What are the key differences between Maxwell and Newton's law?
Newton's laws are purely mechanical. When you throw a ball and make it run fast, by running you make it go faster, etc. The classical mechanics, V equal to U plus AT, S is equal to UT plus AT square, those are all Newton's laws of motion. Maxwell's laws tell you how light, electricity, electromagnetism works. Okay, so it refers to completely different phenomena. It refers to how tube lights work, everything. Essentially, any electromagnetic radiation works. What is radio wave, what is gamma rays, everything is defined by Maxwell's equations. Newton does not touch that. Okay?
Thank you, sir.
One has a continuous force. That means you have a force which is pushing till you meet the friction and it gets stopped. Other one has varying electric field and magnetic field. Okay, these are the changes. And a varying electric field will give rise to a varying magnetic field and vice versa. And it can travel in vacuum. That is the advantage. Vacuum.
Yeah, that is true. Yes.
Sir, have you seen Big Bang?
Nobody has seen Big Bang. Big Bang happened 37,000 million years ago, and I was born 70 years ago.
Sir, so how can you say that these are all made of Big Bang?
Because I have seen that the way the velocities are happening, gave you three pieces of evidence. One is that all galaxies are running away from each other at a certain rate, and that rate increases with distance. So I can wall back. Somebody at 5 meters is moving at 5 meters per second. Somebody moving at 10 meters from me is moving at 10 meters per second. So the obvious question is, where was everybody 1 second ago? And they all came to be at the same place at the same time. So the first major evidence. Okay, except that 1 second is 13.7 billion years. But essentially, the example method. The idea is the same. The second thing is that if the universe did expand in Big Bang, we said the average temperature should be 2.7 degrees Kelvin, which we find. There are a lot of other secondary evidences which all suggest that the universe began in a Big Bang. A whole bunch of second. Everything I don't have to see. Okay, I'm just 70 years old. I have a heart.
Okay, Sir is from DAE, BRC. Sir says he's from TAFR. I'm saying that I'm from ISRO. How are you accepting that whatever we are saying is correct? So somebody would have checked whether I have an ID card from ISRO, or you can actually find out from the way he's talking about spectroscopy and Sir is talking about astronomy. You can say that he has to be a scientist, he knows better than us, and then extrapolating the same thing, you can say that since he is working in astronomy and he has a very good knowledge of astronomy, he should be from a astronomy institute. So then, since he is saying TFR, you should accept that he is from TFR, right? So the same way, you can actually ask, show me the signature, show me the ID of Big Bang. As Sir said, all around us, there is what is called as cosmic ray microwave background, that is at 4 Kelvin, which was expected to, and it is very, very, very perfectly black body. If somebody shows you a plot showing a black body radiation, the error bars on that has to be enlarged so much that is much less than the line width. So that is so perfect black body is one of the best result or signature of Big Bang theory.
Any other questions? Yes. The boy at the you give that fellow. Your left, huh? Then either, huh, bhai, huh?
Sir, different satellite move in different orbits around the Earth, like one like this. How is set those satellites in those orbits?
Oh, that's a question of rocket technology. Depends on how you inject into the orbit. When the rocket goes and leaves the satellite in the orbit, it leaves it in such a way that it goes there, and then the satellites have their own little rockets to make sure that they're exactly where they're supposed to be. Correct, no?
Sir, all the
Want to close? Okay, sorry. One more question we'll take. Huh?
So all the waste generated by the rocket disposals in the space, they're gonna create a very big problem in the future. So how we're going to deal with?
He talked about space junk, and that's a big problem. With the space debris and space junk, we are trying to do something, but there are no good solutions to that problem. One last question.
That is actually a good idea for a startup.
Yeah.
You can come up with something where you can actually effectively remove the space junk, you will be funded like him.
Yes. Yes.
So we know about baryons, which are like naturally they contain a combination of 3 quarks, and if we kick out one, it becomes a meson. So hypothetically, can there be a combination of only 1 quark or 4 quarks?
No.
So,
We have shown that they don't exist. Experimentally, we have confirmed that they don't exist. Single quark objects don't exist. 4 quark objects also don't exist. There are some exotic particles which have an odd number of quarks, but they decay very quickly. There are no stable solutions with more than 3 quarks or less than 2 quarks. Okay? Okay, we'll close the session here. Okay, thank you very much. I hope we have answered your question.
Okay. Before closing, I promised to answer this black hole. I love this story, so I keep on telling to almost everybody, whomever I meet, who wants to know about black holes. All the three of us are sitting here, and the doors are. Sir, if you want to sit or you want to. Okay. So there's only one door. Instead of coming with this mic, I walk in through the door with a tiger. How many of you will stay in this room? How many of you will stay in this room? Tiger, real tiger, ferocious, hungry, man-eating tiger. You still live. It is my pet tiger, it won't eat me, but I won't promise that to you. Okay? Okay. Now, I'll just tell you that I'll keep it on leash, and I promise you that I will not let go of the leash. How many of you will stay here? I am keeping it on a chain. I am not going to leave the chain. I promise you. I am a very good person. I swear I will not leave the chain. How many of you will stay here? Very good. These people don't trust me. I didn't tell you the length of the chain. The length of the chain is so high, it reaches up to there. So now the question is, how many of you would like to stay in this room? Still there are people. Thank you very much. I'm really glad. Okay. So this tiger is like black hole. The length of the leash, whatever I'm holding on to, is what is called as event horizon. If anything comes within that range, the tiger can eat. If it is just beyond the event horizon, means beyond the chain, it will try to eat you, but it may not succeed, it might only harm you. Okay? So, when matter or light is just beyond the event horizon, then as sir mentioned, the light will start bending. It cannot completely devoured by the black hole, it will bend. Okay? So this length of the chain depends on the mass of the black hole. It's not infinite. So that means that even though we have a million mass black hole at the center of our universe, our galaxy, we are safe from it because the length of the chain is much, much smaller. Okay? Now you understand, if a black hole need not eat each and everything within the vicinity because it has its own limits. That limit is event horizon. Thank you very much. So wish you all the best.
Thank you very much to our respective panelists for having such an electrifying discussion. So now it's time to drop the curtain. So before that, I would like to request our respected principal sir, our honorable secretary sir, and our respected physics faculty Ambud sir to please come to the stage so that we can felicitate our respected panelists. Please give a big round of applause, everyone. Everyone, please come forward for a group photo. Please maintain the queue.
Before we end this program, I must admit it was lovely interacting with you, and we look forward for many more occasions. Thank you.
It's an honor for us, sir. The students who have come from outside will stay back. Attention everyone, the students who have come from outside will stay back.